Hello. Right, in this video I'm going to continue with the continuous functions. I talked about continuous functions in part 1, where I believe I ended up with intermediate value theorem. So here let's take a look quickly at the definition of intermediate value theorem. So we will say that if we have a function, I'm going to call the function f, that goes from a domain, call it D to real, where of course the domain is a subset of the real. And we will say that the function satisfies these properties. So we call that intermediate value properties. So we will say that this function f satisfied intermediate value properties if and only if, so this is the definition, so we can use it for every x1 and x2 in the domain. So we pick 2 points where x1, so this is without loss of generality, x1 less than x2, and let's say that is a real constant. So let's say, and I'm going to put the word here, and any real constant, let's call that k, and let's say k is between those two values, that is when you plug in x1 into f of x1 and f of x2, then you will say there exists at least, so there exists at least one constant, so let's call it c, and that c is between these two values that we picked up here, x1, x2 in D. So c is between that, such that f of c, now when you plug in c into x, is equals k. So we know that intermediate value theorem attests this. So if any function has these properties, so if you have a function and you are able to find x1 and x2 where x1 less than x2, and you can find a value in between f of x1 and f of x2, then you will say there exists a c in between this x1 and x2, where c is equals to the value k. So sorry, f of c equals the value k. So today we're going to continue with that's intermediate value theorem. We are going to continue with, as I said, I think it's extreme value theorem. Okay, so this theorem says, in this case you're given f is continuous function. So we have already seen the definition of continuous in the last video, and let's say it's on a closed interval, then I'm going to call my interval goes from a to b. Then we will say f achieves or obtains or attains, so whichever word you want to use, it obtains its max and min on the interval AB. So this theorem is called extreme, right? That's why maximum and minimum. So this is called extreme value theorem. Let's see. Now let me touch a little bit on polynomial. So in your algebra classes you probably have already learned. Suppose you have a polynomial, and I'm going to denote it with a function, and I'm going to write it as a sub n x sub n. So in this case, this polynomial has how many degree? Nth degree. So we're going to write it like this, and then xn minus 1, an minus 1, all the way up to the last term, which is the constant, so a sub naught. So suppose the polynomial has nth degree, and if it is odd degree, that's a keyword. If it is even, then we don't want to use this. Odd degree, so there is corollary that says any polynomial, so we know how polynomial looks like, and if it has odd degree, then we're gonna say it has at least, so at least it has to cross x-axis at least one real. That's the key root. So as long as it is and I would say it's odd power, right? So cubic, you know, is odd power or fifth power. So these are all odd powers. It will cross x-axis at least once. So that's what this corollary says. Okay, the other theorem that I'm going to talk about here is pretty rarely, you hardly hear this, but then you know how this works. So suppose you have a function. So let's say we have a function that goes from a closed interval, that's the key, to another closed interval. And then let's say f is continuous. Of course, since we are in the continuous topic, we're going to talk about continuous. Then what this theorem says is f, the function f has at least let's say the function f has at least one fixed point. So what does this mean? So it means there exists at least one real number p. So it means a real number a or real number whatever. So I already have picked a, so I don't want to use a. Any number. So in this case, suppose there exists x naught, and this has to be in that interval. It can be the endpoint. So we say that it has at least one fixed point, which means is f of x naught equals x naught. So just to give an idea, since I said this is very rarely said or used, so if you have a function x and f of x right here, and f is continuous, so let's say you have some continuous function like this. So what this theorem says is, if, right, you have a point right here, and I'm going to call this x naught, and this is f of x naught, and remember this is f of, in this case without loss of generality, so let's say this is b, and then you have this is a. They're both, let's just do closed, do not plug in anything, a to b. So I can draw a straight line, and you all know this is called y equals x. In other words, this is f of x equals x. So in other words, if I plug in x naught, this is f of x naught equals x naught, right? So this is what you call a theorem of fixed point. So the function f has at least one fixed point. That means there exists at least one real number such that f of x naught equals x naught. So that's basically what fixed naught is all about. Okay, so the next one I'm going to quickly talk about here is inverse. So let's see how or what inverse has to do with continuous functions, right? So if f is continuous, so let's take a look at f is continuous, and again we are on continuous topic. So let's say f goes from D, a domain, to R, is continuous, and let's say f is 1 to 1, and then D is closed interval. So these are all the keywords, right? then F inverse is continuous. So when I'm doing examples, I will go through and prove a lot of the theorems that we have already discussed or put in my other videos. So I believe these are the main theorems and definitions that I will be using in all my examples, and hope this helps you with studying and remembering all the theorems and definitions. Thank you.